This formula will go over how to find the distance between 2 points using the distance formula. So the distance formula is used to find the distance between 2 points. So given 2 points, so the little 1 right here and the 2 just correspond to that we have a first point of x and y and we have a second point that has an x and y. So we are given the formula here. Okay. So the formula says to find the distance, you take the square root okay, so this is going to always be there. We're just going to replace the x2 and the y2 and the x1 and the y1. So where I highlighted are the only 4 spots that we are going to input something. So this all stays the same. So you're going to pick, I'm going to have this be the first ordered pair. So both of these points have, we know that x goes first and y goes second. So you got to pick which one to be x1 and y1. So I'm going to have this be the first ordered pair and then this be the second ordered pair. Now it really doesn't matter. The formula also works if we switch these. So if we do x sub 1 minus x sub 2, as long as we keep this in the same order, as long as we do y1 minus y2. So we can flip these two as long as we flip both of them. So either of these is okay. So it says to take x2, so notice I circle it because I don't want to accidentally use the same number again. So 3 and then minus x1, so that's negative 3. So we have 2 negatives there, so that will make a positive. And then it says to take y2, which is 8, and minus 5. Okay, so again, you would get the same answer if instead we switched the order and we did x1. So if we did negative 3, minus 3, and then we did 5, minus 8. So it doesn't matter. In the end, we'll get the same answer. Okay, so then, in order of operations, we're going to do exponents. We're going to simplify. So 3 plus 3 is 6, and then to the second power. And then 8 minus 5 is 3. Okay, and then if we go over here, negative 3 minus 3 is negative 6. But both of these are both, when you square them, going to make 36. So that's why it doesn't matter. And then 5 minus 8, that's negative 3. And again, when you square both of these, they're both 9. Okay. So now I want to demonstrate, before we finish this problem, I want to pause where we are and I want to demonstrate what we're doing, what we're really doing. So what we're trying to find out by doing this process here in these computations is we're trying to find the distance between the point negative 3, 5, so from the origin negative 3 and then up 5, and the point 3, 8. So over 3 and then up 8. So you're trying to tell me what the distance is between these 2 points right here. But the problem is, since it goes at a diagonal, we can't just count the boxes, unfortunately. If it went straight up, then you can count and tell me this is a distance of 4. If it went vertical, you can tell me how many boxes across that is. But because the slice is through unevenly, it's from here to here, that's not the distance of 1. We can't just count the boxes. However, we could do an eyeball like approach and look and be like, well, that's like 1, 2, 3, 4, 5, 6, a little bit more than 6 it looks like, just by looking at it. So if you get an answer of 12 or 15, that makes no sense. It looks like it is a length of about 6 or 7 long. Okay, so now if I didn't have the distance formula, let's say my teacher did not give it to me and I had to memorize it and I forgot what the distance formula was like, if I were to graph them, I could actually figure this out by making this into a triangle. So since we can figure out vertical and horizontal distance, if I draw a line down here, this is a length of 3 boxes right here. And then if I go across here, this is 1, 2, 3, 4, 5, 6 boxes. So if we look at our work right now, do you see when they have us subtract, they're having us find the difference between here, and that's a length of 3. So that's where the 3 comes from. And then from here to here, when we are subtracting here, we're figuring out how far apart. So that's where the 6 comes from. Now, we've learned that when we have a right triangle, if we want to know what one of the sides is, that we can use a squared plus b squared equals c squared. And we know c has to be the angle that is across from the right angle. So we don't know what c is. So I'm going to have this be a and this be b. So we'd have 3 squared plus 6 squared. So again, we can see how that relates to our formula here. It has a 6 squared and a 3 squared. So far we see that resemblance there. And then 3 squared is 9, and 6 squared is 36. And that's exactly what we would do here. So 6 squared is 36 plus 9. And then we'd have 36 plus 9 is 45. And so if we keep going here, again, we still get 45. And then we have learned that if we want to undo, so we have a square, if we want to undo a square, if we square root both sides, because they undo each other, so if we square root both sides, remember the index here is 2, and you've learned that if you take the index inside over the index, 2 divided by 2 would just make c here. So that's why the square and the square root will undo each other, because it would just make 1 when you divide this index into this exponent. So then we're left with just the square root of 45. So that is why the distance formula has the radical already there, because of this right here. Now, remember, we were trying to figure out how long this line is. So if you told someone, oh, it's square root of 45 distance, people would probably be like, well, what is that? That makes no sense. So if we look at the directions, it says, find the distance, state the exact distance by expressing answers as simplified radicals. So I would write square root of 45 equals, and we would simplify the square root of 45. We can write it as 9 times 5. So we would get 3 radical 5 for the exact. But again, if you told someone, oh, this is a distance of 3 rad 5 or square root of 45, it's not very meaningful to a lot of people. So then it asks you, well, what is that about? That will make more sense to tell someone that the distance is about 6.71. It says round to 2 decimal places, so that means we need to go to 3 actually when it says 2, and see if the third number's 5 or higher, which it is, so it will make the 70 71. So it's about 6.71. And that's kind of what I said to start with that it looked like. So let's go ahead and try another one. Okay, so if we try another one here, it says to find the distance, so let's make it visual. So we have the point 1, 3, and then we have the point 7, negative 5, and it's asking, what is the distance? Well, if one box is about this length, I'm going to go across and be like 2, 3, 4, 5, 6, 7, 8, 9, around 9 or 10 it looks like to me. So that's what we're trying to find here, is how long this is. So if I didn't have the distance formula, I could figure this out by dropping a vertical segment here and a horizontal here and counting the boxes 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6. And then I could use the Pythagorean theorem. Now, instead, we're learning about radicals right now in the distance formula. So instead, we're going to use this formula that we're given here. So to find the distance, take our distance formula. And this is x, this is y, this is x, this is y. Pick one of them to be y1 and one of them to be the second point. And then again, it doesn't matter if I start here, then I go here, and then I go here, and I go here. That's the same thing as if instead you did y2 first and you had 7 minus 1, and then you had -5 minus 3. So both of these would get us the same answer. So then we would have 1 minus 7 is -6. And then 3 minus -5, that would be 8. And again, if we look at our picture here, we have the 6 and we have the 8, just like we have here. And when you square them, even though this one's a -6, when we square it, we're going to have 36 plus 64. And then we get the square root of 100, which the square root of 100 is 10. And that's what it looks like. So if you left your answer as 100, that's definitely not 100 squares in length. So our exact answer is 10. And so we don't have an approximate since it's exactly 10.